Okay, so this is the first screencast of 2015. The purpose of this screencast is to try to explain to you the reason why we have seasons. Obviously, we're talking about the planet Earth because that's where we live. The big yellow thing in the center is the sun. The blue spinning planet is the Earth. And you can see this orientation is describing or showing or illustrating December 21st. And you can see that the Earth is actually tilted on an axis. And in this situation, the North Pole is tilted away from the sun, and therefore you can see right over here at the North Pole, they have 24 hours of darkness. South Pole, a little bit tougher to see here, has 24 hours of daylight. If I show the Earth profile here, you can see that that's the case. So anything north of the Arctic Circle has 24 hours of darkness. Anything south of the Antarctic Circle has 24 hours of daylight in this case. If I hit play to show the Earth progressing through its orbit, we'll get towards more where we are right now, which is, by the way, February 23rd. It's a Monday, and as you can see, we're getting closer and closer to that. We passed that, and now we're up to March 21st. In this case, it says March 20th. It could be the 21st, the 22nd, or sometimes even the 23rd. And this is when the North Pole is not either pointed towards or away from the sun, and therefore we have what's called an equinox. Everybody has 12 hours of daylight and 12 hours of nighttime, hence the name equinox. So no matter where you live, you experience that. And as the Earth continues in its orbit around the sun, we get towards another date, and that is June 21st. And you can see here clearly that the North Pole is pointed towards the sun. All right, sorry about that. The phone rang. Another modeling job. So you can see here the northern hemisphere is pointed towards the sun. For us, because we live in the northern hemisphere, we live in New York, we would experience first day of summer here. We'd have the highest angle of insolation, and that's why the sun would be highest in the sky. And that's why temperatures generally start to go up during the month of June, July, and August, because we're having direct sunlight, we're pointed towards the sun, and therefore have a higher angle of insolation, which is equated to higher temperatures. As the Earth goes in this orientation, you can see 24 hours of daylight for the North Pole, so the vampires now go to the South Pole where they have 24 hours of darkness. As the Earth progresses in its orbit yet again, we can see it moving. June 21st, July, August, September, and we'll stop on September 22nd here. It could be the 21st, 22nd, or the 23rd. And again, the poles are not pointed towards or away from the sun, and instead we have this 12 hours of daylight, 12 hours of nighttime, yet again, also known as the equinox. Put the Earth in motion again, and as we complete the path, we will stop on December 21st. And in this situation, the northern hemisphere, the North Pole, is pointed away from the sun, and therefore this would be the first day of winter for the northern hemisphere. Realize while we have winter in this orientation, the southern hemisphere has summer. And then right over here, as we move along, and we get towards, moving past February, which is kind of where we are right now, and we're getting closer and closer to March, and hopefully less snow. March 20th, 21st, 22nd would be our first day of spring, and it would be the first day of fall in the southern hemisphere. And then as we move in our orbit and eventually get to June 21st, we're going to see that the northern hemisphere is pointed towards the sun, in this case, our first day of summer, and it's the first day of winter in the southern hemisphere. So you can see 24 hours of daylight at the North Pole, 24 hours of darkness at the South Pole. All right, sorry about that again. Another phone call, another modeling job. So here we are, first day of summer for us, first day of winter for the southern hemisphere. If I fast forward to the equinox date over here, first day of fall for us, northern hemisphere, first day of spring for the southern hemisphere. And if I quickly move it to December 21st, our first day of winter, because we're pointed away from the sun. Okay, you can even see that, even notice, I guess, over on here is a little bit easier, that where we live, New York, roughly about here, I wish I could slow the globe down, but I can't. You could see our daylight hours are less, which makes sense, right? We have very short days in December, December 21st, January, very short days, February. If you notice, the days are getting longer now as we're moving closer and closer to 12 hours of daylight and 12 hours of night, known as an equinox. And you can see that. You can see the area of sunlight in the northern hemisphere is getting more and more and more. And now as we move from March to June 21st, you're going to see that the days are going to get longer and longer and longer till finally we have much longer than 12 hours of daylight, and you could see the North Pole has 24 hours of daylight. And then again, as it moves towards September, the days are going to start to get shorter, less sunlight, less daylight, and then until eventually the North Pole has 12 hours of daylight, 12 hours of night. Everybody does. On September 21st and March 21st, 22nd, 23rd again. And that's the equinox. And again, it goes now through its progression, and it comes back to December 21st, which is our first day of winter, and it's the southern hemisphere's first day of summer. So I think I've repeated myself about 30 or 40 times. You can play this back at your leisure and make fun of me for it in school. Have a good day.